Hello everyone, and then welcome to another video. So in this video we'll be treating power in AC circuits. Okay, so I will try to make this video as short as possible, okay, pinpointing the main things you need to know, okay, and then we move on. Okay, right. So in case you are new to this channel, kindly subscribe, hit on the bell icon so that you don't miss out on any uploaded video. Like the video so that it gets pushed to other students who might need this video to help with their academics. And then let me know your questions in the comment section. I'll reply to them as soon as possible. Okay, right. So when we talk about power in AC circuits, remember in my first apply electricity tutorial video, I pinpointed something we call mnemonics, okay, or in any study smart video you could check that in the description. Okay, I talked about mnemonics. Okay, so we know that power is very important. Okay, so in case you don't understand what I'm trying to say or I'm trying to explain, I mean power is equal to VI. Okay, very important. That's how you use mnemonics. You can check more on that in our Learn Smart Not Hard video. Okay, so let's move on to the three kinds of power in AC circuits. Okay, so we have the apparent power. Okay, that's S. It's measured in volt amperes. Active power, that's the P, that's the main power. Okay, it's measured in watts. Okay, and then we have the reactive power, that's Q, measured in VAR. Okay, this is not video assistant referee. Okay, this volt amperes reactive. Okay, right. So let's move on. Okay, right. So these are the three main power in AC circuits. Okay, apparent, active, and reactive power. Now let's dive right into their main formulas. Okay, how to implement the formulas in solving questions. Okay, right. So this is the general formula. Okay, so we have the apparent power squared equals the actual power. Okay, that's the main power, and then squared plus the active power, the reactive power squared. Okay, and then we have the apparent power being equal to the voltage times the current. Okay, and then we have the main power, the actual power, being equal to the voltage times the current cos theta. The reactive power being equal to the voltage times the current sin theta. PF is the power factor. Okay, so the power factor is equal to cos theta. Okay, and then the power factor could also be equal to the actual power divided by the apparent power. Okay, and then again cos theta could also be equal to the actual power divided by the apparent power. Okay, and then we have efficiency. Efficiency is equal to the power output divided by the power input. Okay, and then we have our current. The current square is equal to the I subscript R squared plus I subscript A squared. So we have the apparent and then the main resistor. Okay, right. So you could guess yourself, or you could ask yourself, how do I go by these formulas in case I don't want to memorize them? Okay, so in case you don't want to memorize these formulas, this is the only thing you need to know. Okay, right. So there is only one table you need to know. So let me draw that and then try to prove these formulas to you. Okay, after that you dive right into solving some questions and then you end the video. Okay, so now this is the only diagram you need to keep in mind. Okay, the only diagram you need to keep in mind. Okay, keep this diagram close to your chest. Okay, right. So this is your angle. Okay, and this is your apparent power. Okay, right. So hope you remember something we call SOHCAHTOA. Okay, we have so, we have ka. Okay, and then we have tua. Okay, so this is our trigonometry. Okay, SOHCAHTOA. Okay, but from here you will be most emphasizing on the so and the ka. That's why we have our sine and cos. Okay, now let's see how we come about these formulas. Okay, especially that for the actual power and the reactive power, the active power, and what the reactive power. Okay, now let's see. So this is SOHCAHTOA. It means that we have what? Opposite and then hypotenuse. Okay, so let's draw an imaginary line over here. So when we do this, we have what? A right angle triangle. Okay, so now let's use our SOHCAHTOA. So let's use sine. Okay, so sine theta will give us what? From here you know that we have opposite. So opposite is what? S. Okay, and then divided by what? Hypotenuse, that's what? P. Okay, so in order to find what? S, you know that S, okay, S is equal to what? P sine what? Theta. Okay, right, so this is what? P sine theta. Okay, this is the formula for what? S. Okay, that's what? Apparent what? Power. Okay, now let's check for what? Maybe let's find P. Okay, so for P let's use okay, so let's use cos theta. Okay, so cos theta is equal to what? Adjacent what? Hypotenuse. Okay, so we have adjacent, which is what? P. Okay, and then we have what? Hypotenuse. Okay, hypotenuse is what? S. Okay, so we have P equals S cos theta. Okay, so this will be our value for what? P, and then we know that S is equal to what? VI. So when you substitute into this, we have what? P equals VI cos theta. Okay, so you could use this diagram to prove these formulas. Okay, so for I you could use what? Our main I will be, so this will be our main I, and then we have what? IA over here, and then we have what? IR over here. Okay, so that's how you prove that. So let's see how we solve questions. Okay, so there are some important notes you need to know. Okay, so they are very, very important. There are three. Okay, so the first one is what? A power factor may be either lagging or leading. Okay, so let me clear this one out. Whenever you hear lagging, it means that it's positive. Okay, and whenever you hear leading, it means it's what? Negative. Okay, now so let's proceed. So you have what? A power factor is lagging when current lags voltage. Okay, and then a power factor is leading when current leads the voltage. Okay, so now let's take an example, and then after we're done solving the example, we call it a day. Okay, let's see. So we have what? A single phase what? Motor connected to what? 400 volts and then 50 hertz. Okay, so supply. So a single phase motor connected to a 400 volts 50 hertz supply is developing 10 kilowatts with efficiency of 84% and a power factor of what? 0.7 lagging. Okay, so it means that what? Power factor is what? Positive, is lagging, right? So as stated from here, okay, as indicated from here, lagging is what? Positive, and then leading is what? Negative. Okay, right, so let's dive right into finding the solution to this question. Okay, this is very, very simple and straightforward. So let's write out our parameters. So we've been given what? A voltage. Okay, so we have a voltage of 400 volts. Okay, we have our frequency. Okay, frequency of 50 hertz. Okay, we have what? Yes, power. Okay, so that's our active power. Okay, so that's 10 kilowatts. Okay, and then we have efficiency. Okay, efficiency of 0.84. okay, that's 84%. And then we have what? Power factor. Okay, to be 0.7 lagging, that's positive. Okay, right, so let's see how we go by solving this. Okay, so first we need to find what? Input kVA. Okay, so we know that kVA is our what? Apparent what? Power. Okay, so that's our S. S value, okay? And then we know that we've been given what? Efficiency, okay? So from efficiency we could find what? Since we know that our apparent power, okay, is equal to what? The actual power divided by what? Our PF, okay? So we could notice that we could find what? This is also what? Power input, okay? Input power, okay? So from our efficiency, we know that our efficiency is what? The power output divided by what? Power input, okay? So we could find our what? Power input, okay, from our what? The same formula. So we have a power output divided by what? Our efficiency, okay? Right. And then we know that what? We've been given our what? Power output to be what? 10 kilowatt, okay? So we have 10 divided by what? 0.84, okay? And then that will give us what? It's 11.9, okay? Around 11.9. Let's see, let's say 91 or 905, okay? Kilowatt, okay? So now this is our power input, okay? So from here you could find what? Our apparent power, okay? So we have what? 11.905, okay? Divided by our power factor, that is what? 0.7 what? Lag. Okay, so when you punch this on your calculator, you end up with 17.007, okay, kilowatt kilovolt amperes, okay, kilovolt amperes, okay. Now that's our what? Input what? Apparent what? Power. Let's look at what? Active and what? Reactive components of the current, okay. Now let's proceed. Let's look at the active and what? Reactive, okay. Right, so let's say we have what? We have to find the active, okay. Right, so we have, for B, we know that S is the same as what? As what? VI, okay. We know that already, okay. So now let's find what? Our current, okay. So current is what? S on V, okay. We know S, we've already calculated S, okay. Our apparent power to be what? 17.007, okay, times 10 exponent 3. Hope you know what times 10 exponent 3 is. That's our kilo, okay. Yes, so divided by what? 400 volts, okay. So this will give us a certain 42 point, let's say that's 518, okay, 518 amperes, okay, 518 amperes. So now we have to find what? Apparent and what? We have to find the active and what? Reactive components of the current, okay. So that's what we are trying to do, okay. So now we have what? This is the main current, okay. So remember that I stated that we have what? I squared equals what? Reactive plus what? The active what? Current, okay. So we are finding what? The active and then what? Reactive portion of the current, okay. So now let's proceed. Now we know that IA, okay, is equal to the main current, and then we have cos theta, okay. And then we know that what? Cos theta should be equal to what? The power factor, okay. Right. So now from here you could just find out what? Our apparent current, okay. So our apparent current will be equal to what? Our main current, that's what? 42.518, okay. And then you multiply that by what? Our power factor, because you know that cos theta is the same as what? Power factor, okay. So we have 0.7, okay. So when you punch this, that, you end up with 29, okay, 29.766, okay. That's our what? Apparent what? Current, okay. So now from here we could just use this formula to find out what? Reactive what? Current. So we have what? So we have this, okay? So we have I squared minus IA squared, okay? So from here we have I squared, that's what, 42, okay? So we have 42.518 all squared minus IA, okay? That's 29, okay? 29.766 squared, okay? These are all squared, okay? So that's IR. So now our IR, okay, would be equal to what? 30.361 amps, okay? Amperes or amps, okay? Could be any, okay? Right. So these are what are active and what reactive what current, okay? You could notice that this is very, very simple, okay? Now let's move on to find final what question, okay? So we have to find the reactive, okay? So first we calculated for the input what kVA. Now we are calculating for what the reactive kVA, okay? So that's simple, okay? So that's our what Q value, okay? Now so let's see. So C, okay, is equal to what? Q, okay? You know that Q is equal to VI, okay, sine theta, okay? But from here you don't know what sine theta, okay? But already we know that what sine theta, okay, sine theta multiplied by VI could be just represented as what VIR, okay? Because IR, okay, IR is the same as what sine theta, okay? That's why from the beginning I stated that this formula, okay, once you know this diagram, you can prove other what formulas, okay? So once you use this diagram, you could prove what IR, okay? So let's try proving IR, okay? So now let's see. Let's say this imaginary, okay, and this are what current. So let's try finding IR, okay? So let's use what Sukato, okay? So these are 90 degrees angle, okay? Right, so let's find what, let's use sine, okay? So you have sine theta, okay, of what opposite, okay? So opposite is our what IR, okay? Let's see, okay, we have what our opposites, and then we have what hypotenuse, okay? So hypotenuse is what I, okay, and then opposite is IR, okay? So we have this, okay? So we have what IR is equal to what I what sine of theta, okay? So from here you could notice that we've been able to prove that IR, okay, is equal to I sine theta. That's why initially I stated that once you know this diagram, you could prove every formula, okay? So now let's go back to our question, okay? Let's go back to our question. So from here you could notice that we know that Q is now equal to what? Then we can calculate this by what? Inserting our V value, that's 400, multiplying what IR. IR is what 30.361, and then this will give us 12.144, okay? kVAR, okay? So this brings us to the end of this video. Kindly subscribe, hit on the bell icon so that I don't miss out on any uploaded video, and I will see you in the next video.